Today we're going to be working to write and solve equations using diagrams. I'm going to work with addition and multiplication today, and I'm going to start by modeling these with whole numbers and no variables. So if I ask you to draw a diagram to represent this first one using addition, okay, when we model addition, I'm going to draw a box for each of the numbers I'm adding. So a box for the 4, and a box for the 3. And then we're going to bracket those together, showing they're being combined to make a total of 7. So I don't need to draw 4 individual boxes for 4 or 3 individual boxes for 3. I'm just, again, for each of the numbers in the problem, draw one box and you're putting the value of the box inside. When I go to model the second equation, I'm doing 4 times 3 equals 12. I'm going to do this a little bit differently. So multiplication means I have 4 of something and the value of each is 3. So the number of boxes in my diagram is going to come from that first value. So I draw in 4, and then the value of each of those boxes is 3. I have 4 groups of 3. And likewise, just like I did with the addition one, to show the total of that, I am going to bracket that together, representing that the total there is 12. Seeing this with whole numbers, we're now going to try to apply this with variables when we don't know the value. Okay, so I have 18 is equal to 3 plus x. So just like I did with my addition where I knew both the numbers, okay, when we're adding, we're going to draw 2 boxes because there's 2 things being added, combined together. Again, I don't know what that x equals just yet, so I'm leaving x in the box. And then I'm showing that the combination of those two gives me 18. To solve this, we're going to guess and check. Okay, you might already know what x equals based on your number knowledge. Okay, if you're not sure, it's okay to take a guess and plug it in and see if that would make this true. So let's say you wanted to guess 12. You would take the original equation, 18 equals 3 plus x, and you would replace x with what you think it is. So if you think it is 12, 18 equals 3 plus 12. If you evaluate that out, we'll get 18 equals 15, which we know is not true, which means we know this cannot equal 12. Continue guessing until you catch a number that makes that a true statement. In this one, let's then try x equals 15. And I will replace my x with 15. And then at this point, 3 plus 15 does give me 18, meaning x equals 15 is my solution. Okay, we're going to follow that same process for the multiplication. Okay, and remember when we model this multiplication, I'm going to draw 3 boxes, because 3 is first. Right, and for right now, I don't know the value of the box because I have 3 times y. So I'm going to put y inside. Okay, again, I'll bracket those together to indicate that all of them together makes 18. Okay, just like the addition problem, we're going to guess and check to try to find our answer. Okay, if you know your multiplication facts, this will be a little bit easier. If you're not sure, again, you're guessing until you choose the right number for y. So let's say you thought y would equal 4. Okay, in my equation, I would replace the y with 4. And 3 times 4, if you can look at a multiplication table, only gives me 12, which means that can't be the value for y. So I choose a different number until I get to the point where it is true. Okay, let's try y equals 6. So again, 18 equals 3 times the new value for y is 6. If you check, 3 times 6 does give me 18. Okay, so again, I'm going to box this there as my solution. Today we're practicing this skill with whole numbers and what I like to call friendly numbers. Okay, as we move through the unit, we'll see more difficult questions where we use diagrams with fractions and decimals. Good luck.